Molecular orbital theory. Valence bond theory can successfully explain the formation of hydrogen molecule. Okay, and it can also extend it to molecules like fluorine molecule F2, then ammonia NH3, H2O, etc. It can also explain the bonding and shapes of many molecules, but it has lots of limitations. Okay, limitations of valence bond theory. First point, it could not explain the tetravalency of carbon atom. Okay. Second point, it could not explain the magnetic properties of certain molecules. Okay, magnetic properties. Example, oxygen is paramagnetic. This could not be explained by valence bond theory. Okay. And this theory could not explain anything about the energies of electrons. Okay. Energies of electrons are not discussed in this theory. Also, this theory assumes that electrons have specified areas. Okay, that is another limitation. Okay, also it fails to explain the bonding in electron deficient compounds. Okay, bonding in electron deficient compounds. So, new theory was put forward, which is known as molecular orbital theory. Okay, it explains the bonding in covalent compounds more satisfactorily. Okay, so this was put forward by F. Hunt and R.S. Millikan in 1932. Okay, and according to this theory, electrons in molecules are present in new orbitals known as molecular orbitals. Okay, so in molecules, atomic orbitals lose their identity. Okay, also these atomic orbitals which are associated with atom. Okay, but these molecular orbitals belongs to the whole molecule. That is the difference. Okay, so let us discuss some of the salient features of molecular orbital theory. Okay, first point, in molecules, electrons are present in new orbitals called molecular orbitals. New orbitals called molecular orbitals. Okay. Then, second point, molecular orbitals are formed by the combination of atomic orbitals of nearly same energies and proper symmetry. Okay. Molecular orbitals are formed by the combination of atomic orbitals of same symmetry, okay, of almost same energies and proper symmetry, okay, proper symmetry. Then third point, Molecular orbitals are associated with nuclei of all bonded atoms. Okay, it is associated with the nuclei of all bonded atoms. That means molecular orbitals are polycentric. But atomic orbitals are monocentric because it is associated, each atomic orbital is associated with only one atom. Okay. Next point, number of molecular orbitals is equal to number of combining atomic orbitals. Number of molecular orbitals equal number of combining atomic orbitals. Okay, combining atomic orbitals. Then next point, when two atomic orbitals combine and form two new orbitals. Okay, so one is known as bonding molecular orbital and the other is known as anti-bonding molecular orbitals. Okay, so two new orbitals are new molecular orbitals are formed. One is bonding molecular orbital and other is anti-bonding molecular orbital. Next, sixth point, bonding molecular orbitals have energy lower than the combining atomic orbitals. Okay, and they are highly stable. But antibonding molecular orbitals have energy higher than combining atomic orbitals, so they are less stable. Okay, bonding molecular orbitals. They have energy, lower energy than combining atomic orbitals, but antibonding molecular orbitals have higher energy than combining atomic orbitals. So they are less stable, whereas bonding molecular orbitals are more stable. Okay. Then seventh point, like atomic orbitals, these molecular orbitals are also filled in accordance with Aufbau principle, Pauli's exclusion principle and Hund's rule. Okay. Molecular orbitals are filled in accordance with Aufbau principle, then Hund's rule and Pauli's exclusion principle. Okay. So electrons present in molecular orbitals are filled in accordance with Aufbau principle, Hund's rule and Pauli's exclusion principle. Okay, these are some of the salient features of molecular orbital theory.